Hello guys, I welcome to all of you in this video lecture. In previous lecture, I give you the definition of differentiability of function of two variable. In this video lecture, we will deal with an example and we will check that the given function is differentiable or not. Function of two variables. So let's start with this example. Example is we have given a function of two variable fxy is equal to x square into y square whole upon x square plus y square when xy is not equal to 0 and this is equal to 0 when xy is equal to 0 0. Then check is fxy is differentiable at point 0 0. So let's start its solution. So solution is here. So first of all we will construct the function that is del z minus dz, and this will be equal to epsilon 1 into del x plus epsilon 2 into del y in this form. And if the limit of epsilon 1 if limit of epsilon 1 and limit of epsilon 2 both converges to 0 as x comma y tends to 0 0, then we say fxy is differentiable at origin. Okay, so we know that del x is equal to f a plus h, that is here a is 0, h comma k minus f 0 0, and hk is h square k square whole upon h square plus k square, and we know that f 0 0 is 0. So from here we get del z is equal to h square into k square whole upon h square plus k square. Now we will find the value of dz, and dz is equal to the partial derivative of x at point 0 comma 0 into del x plus partial derivative of y at point 0 comma 0 into del y. So we will find the fx. This will be equal to limit s tends to 0 f h comma 0 minus f 0 comma 0 upon h. So this is for fx into del x, plus for fy we will use this formula, limit k tends to 0 f 0 comma k minus f 0 0 upon k into del y. into del y. Okay guys, so here we know that the f h comma 0 is obtained by putting x is equal to h and y is equal to 0 in the given function. So it gives us 0 minus 0 upon h, and limit h tends to 0 into del x plus again 0 minus 0 upon k into del y. So this value is totally equal to 0. Hence dz del z minus dz is equal to h square k square whole upon h square plus k square, and we will write this is equal to epsilon 1 into del x plus epsilon 2 into del y. So here in place of h we will use del x, and in place of k we will use del y. So we will write it, this is equal to, because h is the change of in x axis, so this is del x del y square upon h square, that is del x square and del y square. Del x plus epsilon 2 del y. So here we can assume that epsilon 1 is equal to 0 and epsilon 2 is equal to del x square into del y upon del x square plus del y square. Okay, so now we will check the limit of epsilon 2 at point 0, 0, that is limit x y tends to 0, 0 of del x square into del y upon del x square plus del y. So we will check its limit is equal to 0. So to check the limit of function of two variable, that is epsilon 2, here we assume that epsilon is any positive number such that del x minus 0 is less than so suppose delta is greater than 0, such that del x minus 0 is less than delta and del x y minus 0 is again less than delta. Then this implies that delta lies between delta x lies between minus delta and delta, and similarly delta y lies between these two values. Now we also know that for all del x square plus del y square is always will be greater than del x square. So if we take this quantity in denominator of left hand side value, so we get del x square upon del x square plus del y square will be less than 1. So from here we multiply both side del y by del y, so we get this value. Now we can take, because we can take this is equal to mod del x square into del y whole upon del x square and del y square minus 0, and similarly here mod del y minus 0, but we know that the del y minus 0 is less than delta, so we say this is equal to epsilon. So this implies that this function minus 0 mod value is less than epsilon, so we can write this limit, the limit of this function at point origin is equal to 0.